All right, well, today's topic is solving motion problems using systems of equations. And you might say, exactly what kind of problems are we going to do? Well, let me show you. It's problems like this. At noon, a car leaves Chicago and travels toward New York. At 2 p.m., a car leaves New York and travels toward Chicago, going 5 miles per hour slower than the first car. If the distance between the cities is 803 miles and the cars meet at 7 p.m., how fast was each car traveling? Now, I know exactly what you're thinking. You're thinking, that's impossible. Well, it's not. In reality, if you'll learn some structure, and that's what I'm going to show you today, how to set this problem up. If you'll learn some structure, you'll find out that a problem like this is easily manageable. But there are some things you have to know first, and that's what I'm here to teach you today. All right? So, word problem, that's okay. We're going to use it solving a systems of equations. How do you start? Well, you got to start with the formula. You got to start with the formula. All right. Well, what is the formula for motion problems? You probably learned it this way. Distance equals rate times time. I like to flip it around. We're going to go rate times time equals distance. Rate times time equals distance. And I'll show you why I did that in just a moment. Now, what does the formula give you? So you start with the formula. And you know what the formula gives you? The formula gives you a chart. All right, you might say, what is that? A chart. I'm sorry, I'm from New Jersey, and I like to joke around with the word chart. All right, well, the formula gives you a chart. And notice where everything comes from. I have a rate column. I have a time column. I like to include an equal sign column, and I'll show you why in just a moment. And we have a distance column. All right, so your formula gives you your chart. Now, with your chart, you want to label your rows. So I have row 1 and row 2. I look back at my problem and I see that I have the first car leaves Chicago and travels to New York. And so I'm going to label the first row C to NY, Chicago to New York. I see that my problem talks about a second car leaves New York and travels to Chicago. And so I'm going to call my second row New York to Chicago. All right, just some structure. Now, if you look at the chart, there are 6 blocks that are open. We have 6 spaces that we need to fill. And you might say, well, I don't have any idea where to get started. Well, that's why I'm here, right? Let me show you exactly where to get started. Always fill in the variable column first. There will be a column with variables, X and Y, and we want to fill them in first. You say, well, Mr. Sharvey, where do I get the variables from? Well, you just got to look at the problem and figure out what the problem is asking you for. This problem says, how fast was each car traveling? All right, how fast? Is that a rate? Is that a time? Is that a distance? And hopefully you say that's a rate. So X is the rate from Chicago to New York. Y is the rate from New York to Chicago. Fill in the variable column first. All right, you can do that. That's not hard. If it were time, it would ask you how long. If it were distance, it would ask you how far. And so fill in the variable column first. All right, great. We're down to only 4 empty blanks. Look back at your problem, see if we can find time or distance. And remember, time would be Chicago to New York. Distance would be Chicago to New York. How far that car traveled, and such for the second as well, New York to Chicago. All right, well, let's take a look. At noon, a car leaves Chicago and travels to New York. If you look at the bottom of the third line there, the right-hand side, it says the cars meet at 7 p.m. All right, so this first car traveled, it left at noon, and it met the other car at 7 p.m. Noon to 7 p.m., 7 hours. That's not hard. Looking at the second car leaves at 2 p.m. And again, they meet at 7. 2 to 7, 5 hours. And now we have the time column completed. All right, we've got 2 columns down. We need to figure out the distance column. Where in the world are we going to get the distance column? Well, look back at the formula. Rate times time equals the distance, right? That's the formula. Rate times time equals the distance. Now, when you look at the problem, the only thing that talks about distance is it says the distance between the cities is 803 miles. Now, that's not the distance the first car traveled, and that's not the distance the second car traveled. All right, that's a total distance. So that's not what's going to go in the blank. You can't put 803 in for each. They each didn't travel 803 miles. But look, your formula tells you what to do. Take the rate and multiply it times the time. right? Rate times time equals, hence my equal sign, 7x. So x times 7 is 7x. And do the exact same thing for the second row, y times 5. And we all know that y times 5 is 5y. All right, so there it is. We have a completed chart. We are halfway there toward getting our two equations. And again, that's what I'm going to try to show you today. So some structure. Start with the formula. Allow the formula to give you the chart. Label your rows. Fill in the variable column first. Oftentimes, the distance will be the result of multiplying the rate times the time. All right, well, what's next? Well, here's next. As we try to get our equations, remember, the equations there will be two possibilities. Each equation will either be a total equation or a comparison equation. Now you might say, well, where do you get the equations from? Well, it's easy. You get the equations from the variable columns. Let's look at the distance column. The distance column has variables in it, 7x and 5y. And so we get the equations from the variable columns. So there's going to be a distance equation. And I'm going to deal with the distance equation first. And we have to decide, is the distance equation a total or a comparison? Well, how do you decide? You have to go back up into the problem and look at what it says about distance. It says the distance between the cities is 803 miles. You know, what's happening? One car starting at Chicago and heading to New York. The second car is starting at New York and heading to Chicago. And when they meet, that's 803 miles. And so that's a total. When you make that decision, then it's easy to come up with the equation. The equation then becomes very simplistic because every total equation has this template. The first plus the second always equals the total. Every time. If it's a total equation, the first plus the second equals the total. All right, what's the first? Look at your chart. 7x, right? And we're talking about distance. That's the distance the first car traveled. What's the distance the second car traveled, right? 5y. And what's our total? Go back up to your word problem. What was the total distance? 803 miles. Hey, we've got the first equation. Let's get to that last equation. All right, where's it going to come from? Remember, the equations come from the variable columns. So we've got a rate column with variables, x and y. Now again, we got to go back to our problem, and we got to find out what our problem says about the rate. Well, if you look here at the end of the first line, it says at 2 p.m. a car leaves New York, I'm right here, and travels toward Chicago going 5 miles per hour slower. Okay, it's the only thing that talks about rate, 5 miles per hour slower. Is that a total or is that a comparison? Well, slower is a comparison. Faster is a comparison. Longer is a comparison. Shorter is a comparison, etc. That's a comparison. All right, a comparison equation has a little bit different template. And let me show you that. Here's the template for a comparison equation. The first equals the second, but then we have to do something to make sure that they're equal. So let me show you. All right. So what is the rate from Chicago, the car going from Chicago to New York? Look at your chart. Your chart will tell you. The rate is X. I'm putting in X. What is the rate of the car going from New York to Chicago? It's Y. And so I put in Y. Now, here's the last thing. How in the world do I figure out what to do with this 5 miles per hour slower? Because the two aren't equal. They are compared. Here's what I tell my students to do. Just label which one's slower or faster, longer or shorter. The second is slower. So what do you have to do to something that's slower? Well, you may still not know. So why don't you pick it a mile per hour. I'm going to go 100 miles per hour. If the first car was going 100, the second is 5 miles per hour, it's 95, right? And what would you have to do to make it an equal equation? You would have to add 5 to the slower side. Hey, that's what we do here. You got to add to the slower. There's my comparison equation. Hey, two equations, two variables. It's a systems of equations. How do you solve them? Hey, you can solve them by graphing. We're not going to do that. You can solve by substitution or the elimination method. Hey, this is set up well for substitution, and away you go. All right, that's it.